In this video, we are going to have a look at Grignard reactions, and this reaction involves the use of organomagnesium halides. And if you take this reaction with ketones, you should be producing a tertiary alcohol, and aldehydes will give you secondary alcohol. So let's look at the general formula for Grignard reagents. We have R, Mg, and X. Okay, so this is the formula, but usually when the reaction takes place, the alkyl group, which is the R, is assumed to have a lone pair, which means it's going to be negative, and then we have the MgX. Alright, now it doesn't only react with ketones and aldehydes to give you tertiary or secondary alcohol, it can also react with esters, nitriles, and other chemicals. But then in this video, we'll focus more on some few of these reactions. Now, the solvent that is used in this is ether. The general equation, we have Rx, that is your alkyl halide, which is going to be treated with diethyl ether, CH3CH2O, CH2, CH3, and then we are going to have R, Mg, and X. Now the interesting thing here is when a Grignard reagent is formed, we have and we also have magnesium here. So magnesium Mg in diethyl ether. So what happened is we have the magnesium inserting itself between the R and the X. Now the X over there could either be a chlorine, a bromine, or iodine. Now fluorides don't partake in this reaction. So what happens is if magnesium is able to insert itself between the alkyl group and the halide, then it induces a polarity where the alkyl group bears a negative charge, specifically the carbon bearing a negative charge. So it's going to behave more like a carbanion. So this side is becoming partially positive and the alkyl group bears the partially negative charge. Now, once the carbon becomes partially negative, it also makes it to become more reactive. So what we have here is a Grignard reagent, which is also known as organomagnesium halide. Organomagnesium halide. All right. Now, let me give you some few examples of how the Grignard reagent is prepared. So let me just put the example. Now, if you have bromobenzene, so this is your benzene ring with a bromine attached. If you treat this with 1 magnesium and 2 ether as a solvent, the ether is acting as a solvent, then what you should be expecting is that you are going to have the benzene ring, but this time you're going to have the magnesium Mg coming in between the bromine and the carbon bearing it. So you can see that this carbon here, which is a tertiary carbon, is going to carry your partially negative charge, while the magnesium is going to be partially positive, because magnesium is a metal and its electropositivity is very high compared to that of carbon. Now again, if we also have So this one over here is, that is 2-chlorobutane. So alkyl halide. Again, if you treat this with magnesium metal, and ether, what we are going to expect is that we are going to have, so we have this, and over here we are going to have the MgBr. So it's very easy to identify what the Grignard reagent is going to look like if you are given a particular maybe alkyl halide. Okay, now Grignard reagents react with aldehydes to form secondary alcohol. So let's look at the mechanism involved in this. So over here I have pentanal. So pentanal is going to look like this. So this is an aldehyde, and we have the Grignard reagents over here, MgBr, and as you know, this is partially positive and the carbon here is partially negative. So what happens is this carbon is going to act as a carbanion and attack the carbonyl carbon, forcing this double bond to break. And as a result of this, we are going to have an oxyanion so this time we have so let's see, 1 2 3 4 5 6. All right, so this is a O with 3 lone pairs and a negative charge, and then we have a hydrogen attached. Okay, all right, so the next thing that is going to happen is we have O with 3 hydrogen atoms, which is making it to be positively charged, and then this is going to reach out and pick a proton, so it's getting protonated. As a result of this, we are going to have a secondary alcohol, and water, H2O. So this is how we get secondary alcohols when we react Grignard reagent with aldehydes. So let me call this one, and then we have, secondly, we can also have Grignard reagents reacting with ketones to form tertiary alcohol. So I have a cyclohexanone, so this is the Grignard reagent, CH3 MgBr. Again, carbon is partially negative and magnesium is partially positive. So we are having this coming in, attacking the carbonyl carbon, forcing a double bond to break, and we are going to have this intermediate where the oxygen bearing a negative charge. So of course we expect that the magnesium bromide is going to hang around this place since it is positively charged. All right, and then we are going to have the methyl group over here. So this is going to be a reaction intermediate. Now we have the acid coming in here, so H3O plus, so HOH2, so there you have it. We're going to have a tertiary alcohol and a CH3 over here, magnesium bromide with water. Alright, so this is a ketone reacting with the Grignard reagents, and we are having a tertiary alcohol. And also we can also have, so far here we have aldehyde, ketone. Now Grignard reagents can also react with carbon dioxide, and you are going to have carboxylic acid. So let's say this is an alkyl group, and then we have MgX, where X is your halogen. Okay, if this is your carbon dioxide, C double bond O, the alkyl group is going to attack this carbon, forcing one of the double bonds to break, and then you have the electrons thrown to one of the oxygen atoms, and so we are going to have R, C double bond O, and then the oxygen. We have one of the oxygens, 3 lone pairs, and a negative charge. So what else can we do? Remember, we are going to have MgX. So if we have an acid or water, so I'm putting here HOH2, oxygen with a positive charge. This is going to reach out and pick the hydrogen getting protonated, and the result is going to be a carboxylic acid. So we have R, C double bond O, and OH. Okay, that means we also have water in the system as a byproduct. So this is how you get Grignard reagent reacting with carbon dioxide to give you carboxylic acid. Now, how does it react with esters? Remember, I mentioned that it doesn't only react with aldehydes and ketones, but it can also react with esters, nitriles, and even epoxides. Okay, so let this be your ester. So we have methyl ethanoate, CH3, and the Grignard reagent, a methyl group attached to magnesium bromide. Now again, this carbon will attack the carbonyl carbon, forcing this bond to break, and we are going to have this intermediate. So remember, we have a methyl group attached, so CH3, and then your O minus with 3 lone pairs. Now this is not stable, so it is going to try to stabilize itself. We have OCH3 over here. Now in doing so, one of these guys have to leave, and then good leaving group there is the methoxide. So if this comes in, it's going to kick off the methoxide, and we are going to have a ketone. So we have a ketone, double bond O, and then the methoxide, OCH3, and a negative charge. Now what is going to happen next is that we'll have another equivalent of the reagents, that is the Grignard reagents, coming in. So again we have CH3 MgBr. Now this carbon again attacks the carbonyl carbon of the ketone, throwing the electrons to the oxygen, and we are going to have Alright, so that is the intermediate. Again, we'll have the MgBr hanging around here. So if you introduce an acid, H3O plus, the oxygen with a negative charge is going to reach out and pick a proton, getting itself protonated. And so you should be expecting to have a tertiary alcohol. So there you have it, your tertiary alcohol, and then the water, as well as the MgBr. So that's how Grignard reagents react with carboxylic esters to give you a tertiary alcohol. There are other reactions that we haven't covered yet, so please do subscribe and turn on the notification for the next tutorial.